Some of the incredible graduate research here at Trent has led to the development of a synthetic blood substitute for forensic bloodstain pattern analysis, what we call the SBS. Now, this is not your typical Halloween fake blood. It's been designed to mimic the chemical and the physical properties of blood, to not only look, but to act like real blood. This affordable innovation in forensics eliminates the health, safety, and ethical concerns of using human or animal blood for teaching, research, and crime scene reconstruction. We can use it in forensic work instead of using real blood, like pig or sheep's blood, which are biohazards that require prior approval. Instead, I could bring the synthetic in here now, we could throw it around everywhere and pretend to be Dexter for a while. Pretty cool, right? Well, you see, blood's a pretty unique fluid, and we scientists tend to get a little skeptical. If you've ever bought fake blood, you might be wondering, well, how realistic is this synthetic? Is this something that would hold up in court? If I were to place some of it on the floor here and smash it with this microphone, would it react the same way real blood does? To test this, we need to know a little bit about bloodstain pattern analysis. This is an impact pattern. It's created when an object strikes liquid blood, such as in a stabbing, a shooting, or a beating. Now we can work backwards from this pattern to determine a three-dimensional area of origin where the impact occurred. It's what you see them trying to do on CSI using all those strings. My research tested to see if the SBS behaves like real blood when impacted. I hypothesize if this is the case, we should be able to accurately estimate this three-dimensional area. Secondly, a pattern made with the SBS should not be any different than a pattern made with real blood. Now, using this lovely impact device you see here, I made patterns using the synthetic and using sheep's blood at the same known origin. Students in the forensic science program analyzed these patterns and relayed their findings back to me. I statistically compared this data to see if there were any differences between the known and between each other. As it turns out, there are not. Based on the accuracy of these estimations and their precision compared to real blood, it appears that the SBS is behaving like real blood when impacted. Now, while there are many areas of BPA where the SBS still requires testing, my research presents an initial validation for the use of a synthetic blood substitute when it comes to making an impact. Thank you.